Welcome to Daikin web-based training. When a problem occurs in an air conditioner, a malfunction code will be displayed on the remote controller in order to communicate what the problem is to the user. When service persons come to repair the air conditioner, they can determine the specifics of the malfunction in question based on the malfunction code. This course will provide you with an opportunity to learn about how to diagnose the problem when the L5, L8 or L9 malfunction code appears. Let's go over what we will be learning in this course. First, we will look at in what situations the remote controller displays the L5, L8 and L9 malfunction codes. Next, we will look at the causes of the L5, L8 and L9 malfunctions. Finally, we will learn how to diagnose and rectify the L5, L8 and L9 malfunctions. Now, let's look at in what situations the L5, L8 and L9 malfunction codes appear. The type and number of compressors used in a VRV3 outdoor unit differ depending on the model. Only one inverter compressor is used in RXYQ5 and 8. One inverter compressor and one standard compressor are used in RXYQ10 and 12. One inverter compressor and two standard compressors are used in RXYQ14, 16 and 18. There are two types of compressors. One is an inverter compressor that operates on an inverter power supply, and the other is a standard compressor that uses a regular power supply. The L5, L8 and L9 codes appear in the event the inverter compressor malfunctions. The L5 code is displayed when there is a problem with the inverter compressor itself. The L8 code is displayed when there is a problem with the current flowing through the inverter compressor or inverter circuit. The L9 code is displayed when the inverter compressor does not start up properly. Let's take a look at an actual inverter circuit. An inverter compressor varies its rotation speed in order to adjust its operating capacity, and thus requires an inverter PCB. The inverter PCB is mounted behind the control PCB in the control box. The inverter PCB contains a diode module that converts alternating current to direct current, an insulated gate bipolar transistor that converts direct current to variable alternating current, a control circuit that regulates the rotation speed of the compressor, and protection circuits. The L5, L8 and L9 codes are displayed on the remote controller when the protection circuit in the inverter PCB detects that a problem has occurred in the inverter PCB or inverter compressor. From the following page, we will learn the details of the L5, L8 and L9 malfunctions. Now, let's look at the causes of the L5 malfunction. The L5 malfunction occurs when an excessive level of current is detected by the output current detecting means during startup and operation of the inverter compressor. The operating current of an inverter compressor is normally less than 15 amperes, regardless of the frequency. If the output current to the compressor reaches or exceeds 32.3 amperes during startup or operation of the inverter compressor, it is determined to be the L5 malfunction. Based on the fact that the abnormal rise of the operating current is observed both during startup and operation of the inverter compressor, the causes of the L5 malfunction are considered to be a short circuit of the DM or IGBT in the inverter section, or a short circuit of the compressor coil. The L5 code also appears when there is a misdetection by the protection circuit on the inverter PCB. Let's now look at the causes of the L8 malfunction. The L8 malfunction occurs when current at a prescribed level or higher is detected by the output current detecting means during operation of the inverter compressor. The differences from the L5 malfunction are that the output current detecting means does not determine the L8 malfunction during startup, and different current conditions are used to determine the malfunction. There are two current conditions used to determine the L8 malfunction. One is when the output current detecting means detects output current of 16.1 amperes or higher for at least 260 seconds, and the second is when it detects output current of 19.0 amperes or higher for at least 5 seconds. In either case, it is determined as the L8 malfunction. The primary causes of the L8 malfunction are liquid compression due to liquid back as a result of wet operation, where some liquid refrigerant returns to the compressor without being completely vaporized. Another cause can be an increase in the torque load due to insufficient oil in the compressor. The L8 code also appears when there is a misdetection by the protection circuit on the inverter PCB. Let's now look at the causes of the L9 malfunction. A VRV3 outdoor unit has a function to detect the position of the rotor inside the compressor that corresponds with the inverter output frequency. The L9 malfunction occurs during inverter compressor startup, when the detected position of the compressor rotor does not correctly correspond with the output frequency. The primary causes of the L9 malfunction include the mechanical locking of the compressor and liquid compression due to liquid back to the compressor during startup. The L9 code also appears when there is a misdetection of the rotor position by the protection circuit on the inverter PCB. Before going into the diagnostic methods, let's understand what inverter control is, which is necessary to diagnose the malfunction codes. There are two protection circuits on the inverter PCB. One is the output current detecting means, and the L5 and L8 malfunctions are detected here. The other is the current detecting means mounted on each phase on the IGBT output section, and the L9 malfunction is detected here. There are two types of malfunctions detected by the protection circuits on the inverter PCB. One is a malfunction that occurs during startup operation, and the other is a malfunction that occurs during normal operation. Startup operation refers to when the system is operating at an inverter frequency of lower than 50 Hz, while normal operation refers to when the system is operating at an inverter frequency of 50 Hz or higher. The operating current of the inverter compressor is 15 amperes or lower, regardless of during startup or normal operation. The L5 malfunction is detected when the measured current exceeds 32.3 amperes, even for an instant, regardless of during startup or normal operation, which results in stoppage of the inverter compressor and placing it in a standby state. The L8 malfunction is detected when the measured current reaches or exceeds 16.1 amperes for 260 seconds, or 19.0 amperes for 5 seconds during normal operation, which results in stoppage of the inverter compressor and placing it in a standby state. The L9 malfunction is detected when the compressor rotor is in the wrong position in relation to the output frequency during startup, which results in stoppage of the inverter compressor and placing it in a standby state. Note that detecting the above-mentioned abnormalities once does not confirm any of the L5, L8 and L9 malfunctions. The compressor repeats stopping and restarting until the number of stops reaches a certain level, at which point the malfunction is confirmed. The respective code will be displayed on the remote controller, and the system will not try restarting. This type of control is called retry control, and the number of retry times differs depending on the malfunction. Now, let's take a look at the positioning of the parts to be checked during the diagnosis. When diagnosing the L5, L8 or L9 malfunction, it is necessary to check the inverter compressor and the circuits that drive the compressor. Before going into the diagnosis, let's first look at the positioning of the parts using pictures of an actual unit. The power supply is located here and looks as shown in the picture. The inverter compressor is located here and looks as shown in the picture. The inverter PCB is located behind the control PCB. Now, let's learn what to do before checking the inverter PCB and the actual positioning of the area to be checked. First, remove the front panel of the control box where the control PCB is housed. The front panel is held in place with 2 screws, so remove those. Then, lift and pull the front panel forward. Now, the area to be checked on the inverter PCB is exposed. Specifically, the IGBT, namely P2, N, U, V, and W on the circuit diagram, is the area to be checked on the inverter PCB. Let's now look at the diagnostic method for the L5 code. Use the transistor check function of the control PCB to check if there is a short circuit on the inverter section. First, turn the power off, remove the power supply cover on the inverter compressor, and disconnect the wiring connected to the terminal. Next, turn the power on, and when the outdoor unit becomes ready to operate, Set the transistor check function to on using setting mode 2 of the control PCB. When the voltage is output from the wiring disconnected from the compressor terminal, measure the voltages between the phases at the respective terminals. If the voltages between the phases are the same, then there is no problem with the inverter PCB, and you may proceed to checking of the compressor. When the voltages between the phases differ 5% or more, or when the L5 code is displayed after the transistor check function is set to on, then there is a problem with the inverter PCB, and you must check the inverter section. When there is a problem with the inverter section, conduct a transistor check. Turn the power off, wait for 10 minutes, and disconnect the wiring and connectors connected to the inverter PCB. If it is difficult to disconnect the wiring on the lower area of the PCB, disconnect it at the power supply terminal. A transistor check is done by measuring the resistance or voltage using a tester on the P2, N, U, V, and W terminals on the inverter PCB. There are two ways to measure. One is using an analog tester, and the other is using a digital tester. When using an analog tester, refer to the top table on the screen. First, while placing the positive probe on the P2 terminal, place the negative probe on the U, V, and W terminals to measure the resistance. If the measured values are within the criteria range, there is no problem. Next, while placing the negative probe on the P2 terminal, place the positive probe on the U, V, and W terminals to measure the resistance and determine if it is OK. Then, while placing the positive probe on the N terminal, place the negative probe on the U, V, and W terminals to measure the resistance and determine if it is OK. Finally, while placing the negative probe on the N terminal, place the positive probe on the U, V, and W terminals to measure the resistance and determine if it is OK. When using a digital tester, make sure that it has a diode check function and determine whether there is a problem while referring to the bottom table on the screen. The measuring points are the same as when using an analog tester. First, while placing the positive probe on the P2 terminal, place the negative probe on the U, V, and W terminals to measure the voltage. If the measured values are within the criteria range, there is no problem. Next, while placing the negative probe on the P2 terminal, place the positive probe on the U, V, and W terminals to measure the voltage and determine if it is OK. Then, while placing the positive probe on the N terminal, place the negative probe on the U, V, and W terminals to measure the voltage and determine if it is OK. Finally, while placing the negative probe on the N terminal, place the positive probe on the U, V, and W terminals to measure the voltage and determine if it is OK. If any of the measured values are outside the criteria range, there is a problem with the transistor, and the inverter PCB must be replaced. Before checking the compressor, make sure that the power is turned off. Remove the power supply cover on the compressor and disconnect the wiring connected to the terminal. Then, measure the resistance between the phases of the terminal using the resistance measurement mode of the tester. If the measured resistance is 0 ohms or open, then there is a problem with the motor coil inside the compressor, and the compressor must be replaced. If the measured resistance is approximately between 0.3 and 1 ohm, then there is no problem with the compressor, and the malfunction is likely caused by a problem with the inverter PCB. Let's now look at the diagnostic method for the L8 code. First, remove the power supply cover on the compressor, attach the clamp meter to the terminal, and turn the power on. Measure the current after operation starts. If the clamp meter detects an abnormal value or continuously detects 16.1 amperes or higher, or 19.0 amperes or higher for a predetermined period of time, measure the operation data and check if there is wet operation. If there is wet operation, check the refrigerant circuit and rectify the cause. If the measured current reaches or exceeds the predetermined abnormal level while no wet operation occurs, then check the compressor's operating noise. If there are strange noises, they are likely caused by an increase in the torque load due to abrasion of the compressor bearing, and the compressor must be replaced. Let's now look at the diagnostic method for the L9 code. When the compressor cannot be activated, the cause is likely a problem with the refrigerant circuit. To check the circuit, attach the pressure gauges to the service ports on the outdoor unit. Note that the positions of the service ports to which the gauges are attached differ between cooling and heating. Also, make sure that the stop valve is open. After the pressure gauges are attached, check for a pressure difference between the high and low pressure sides. Normally, there is virtually no high and low pressure difference during startup of an inverter compressor. If there is a high and low pressure difference of 43.5 psig or higher during startup, the compressor will not start up, so check for the cause. A bypass valve is connected between the high and low pressure refrigerant circuits in order to eliminate the pressure difference between the high and low pressure sides when the compressor is off. Normally, when the compressor is off, the bypass valve is open. If it is closed, it causes a high and low pressure difference. Therefore, confirm that the valve is open. The electric symbol for this bypass valve is Y1S, so locate it on the electric diagram. You can see that Y1S is connected to the X7A connector on the control PCB, so locate it on the actual control PCB. When the X7A connector is located, remove it and measure the voltage at the PCB connector while the outdoor unit is on. If there is no voltage, then there is a problem with the control PCB and it must be replaced. If there is voltage, then check the resistance of the bypass valve coil. If there is a problem, replace the coil. If there is no problem with the coil, check the refrigerant circuit next. Similarly to the diagnosis of the L8 code, the current is measured to check the refrigerant circuit. Remove the power supply cover on the compressor, attach the clamp meter to the terminal and turn the outdoor unit on. The L9 malfunction occurs during the compressor startup, so check the behavior of the compressor during the startup. If the compressor does not start up, then the cause is likely that the compressor has locked up mechanically and it is necessary to replace it. If the compressor starts up, measure the operation data and check if there is refrigerant overcharge. If there is, then rectify it.